One of the more recent developments in chemistry is green chemistry. So, the overarching theme of green chemistry is to be a more environmentally sustainable. So, there are a lot of different aspects. In fact, there are 12 different points related to green chemistry if you look at a green chemistry textbook. One of the important ones is to try to reduce or eliminate the amount of organic, volatile organic, and toxic solvents that we use. So, we've used a lot of different solvents in the reactions that we've already covered. We've used alcohols, we've used methylene chloride, we've used toluene and hexanes, we've used ether. This experiment doesn't use a solvent at all during the reaction. So that's why it's considered a green reaction. When you mix the organic starting material and the base, you grind them together in a mortar and pestle. You do not use any solvent. Now, eventually, we do use some solvents in the rest of the reaction, but we have eliminated quite a bit because the reaction is not run in a solvent. So this reaction is the Wittig reaction. You may have been taught as the Wittig reaction, and I'm not trying to be fancy or anything. I took 5 years of German, in middle school and high school and college. So it's sort of ingrained in me. In terms of German, the W is actually the V sound, and if you look at other words in German, the V is actually the F sound. So it gets a little confusing, but this is, to me, I keep saying the Wittig reaction. That's how I was trained. So a Wittig reaction takes a ketone or aldehyde. You react it with an ylide, and an ylide is a compound that contains two charges. In this case, we're making it from a phosphonium chloride. You take a phosphonium chloride and you add a base. You create a nucleophile that can attack the carbonyl, and eventually it closes into a four-membered ring called an oxyphosphatane. And then that four-membered ring, because it's not stable, falls apart. You create triphenylphosphine oxide as a byproduct, and that's important in the post-lab workup. And then an alkene of some kind. So you take a ketone or aldehyde, you have your triphenylphosphonium material, you create an alkene through the course of this reaction. So the base you're using is potassium phosphate, tribasic potassium phosphate, and you quite literally grind the potassium phosphate, your triphenylphosphine material, triphenylphosphonium compound, and the starting material chloride. You grind them all together and you get your product from that. This is a very highly conjugated product, which can provide some issues when you're looking at the spectroscopy, which is why we have limited the spectroscopy. So very, very important green chemistry, reducing the amount of waste, reducing the amount of volatile organic solvents that are used, and we do that by eliminating them altogether in this reaction using a very kind of unique reaction, grinding the materials in a mortar